Welcome back. Today we're going to be looking at section 4.1, linear functions and their graphs. Just a quick note, this is the only section in chapter 4 that we're going to be going over, so it's really important to pay attention to this one and get ready for this test. This one's going to be a quick turnaround, but hopefully it's some material that you've seen before, whether in high school or in previous classes. So I don't think it'll be that bad. And we've already talked about linear equations in chapter 2. So I'm hoping that this seems like a little bit of review and applying what we've been learning about functions, specifically to the linear ones. Without further ado, let's go ahead and get started on section 4.1, linear functions and their graphs. So the first thing in this section that's really important to look at is the 5 forms that we're giving you. The equation, which is this first one, which is that classic equation you've seen, y equals mx plus b, where m is the slope and b is the y-intercept. And then the function form, which is exactly the same. We're just replacing that y with an actual function, f of x, where x is the input and f of x is the output. We've got tables like we've been looking at before. We've got graphs. And then we've got this one special form that's going to be really helpful in solving a lot of these equations, which is the point-slope form. You'll notice there's a y2 and a y1 and an x2 and an x1. And when we go to solve these, when we go to plug and chug stuff in, though this is correct, and you could pick either x1 or y1 to plug in, or x2 and y2, what we're going to typically do is leave the first one alone as a dependent variable and use a point to plug into the ones. That way you still have a function, because if you just plug in all the points, all you'll result in is probably a true equation, like 3 equals 3 or something. So without leaving an independent and dependent variable on either side, we don't really have a function, we just have a true statement. So that's kind of just a side note on that point slope form. Let's go ahead and get started. We are going to start by calculating slope, which we've already done before when we calculated average rate of change. Now we're just going to apply it specifically to a line. And on a line, if you think about any line you could possibly draw, no matter which point you pick, the slope is going to be exactly the same. So you pick a point, let's say right here, you've got a slope that looks kind of like that. You pick a point right here, you got a slope that looks kind of like that. If you were to think of a different polynomial function that looks kind of like that, maybe a cubic function, you could still find the average rate of change from red to red point, but it's not going to be the slope of the line. Your slopes are going to change everywhere you go. So that's the key thing here. A linear function is a constant slope the entire time through. All right, so let's find the slope then. If you recall from chapter 2, and from up above, the slope is y2 minus y1 over x2 minus x1. Side note, you'll notice if you move that denominator over by multiplying, you'll result in that equation we just had earlier, the point slope equation. And then we're just going to plug and chug some points. So 4 minus 3 over 0 minus 2. Careful with our negative signs, and we're going to end up with 1 over negative 2 as our slope. And I think this equation, or this problem, asks us to determine whether it's increasing or decreasing. And we're going to say because the slope is negative, or because the slope is less than 0, m is less than 0, implies that the line is decreasing. And that is the first step to a linear equation, is can you find the slope? More specifically, that one is slope between 2 points. All right, now we're going to use the exact same steps, but find the equation of the line, not just the slope. So for try it 3, we're going to hop down and we're going to say they gave it in a little different form, but it's the exact same thing. They gave us 2 points, 2, comma, negative 11, and a second point, 4, comma, negative 25. Maybe we could label these as x1, y1, x2, y2, just so we know which ones we're referring to as we go to plug and chug some numbers into the equation. And it says find the equation for a line. But we can't really find the equation before we find the slope, which is why we started with that. So let's go ahead and find that slope first. M equals, remember the y2 minus y1 over x2 minus x1. So we're going to negative 25 minus negative 11. Be really careful with those negative signs. And 4 minus 2. Bottom's a little easier. And so negative 25 minus negative 11. If you can do it off to the side, that's okay. We're going to end up adding them. You know how negative and a negative make a positive. We're going to end up with negative 14 over 2, which is negative 7. So we got ourselves a slope. And notice, if you want to make a side note, this function's decreasing at every point. Now, they didn't ask us for the slope. They asked us for an equation of the line, typo, equation of the line. So we're going to take that point slope formula, that special one, the last one that we gave you, and we're going to plug in some numbers to it. So you remember y minus y1 equals mx minus x1. And we're just going to plug in the three things we have. So maybe we'll use x1 and y1 from up here and the slope from here to the m value and get y minus negative 11, careful with that negative sign, times negative 7 x minus 2. And we have ourselves an equation of a line in point slope form. But if you read the question carefully, they didn't ask us for point slope form, so we're going to have to do a little bit of algebra from chapter 2 in order to get it in the format they want. So they asked us for slope intercept form. Well, we'll just do a little bit of distribution, a little bit of moving stuff around to get y by itself. So we got y plus 11, combine those two negative signs, equals negative 7 times x minus 2. First things we're going to do, if you remember the don't call me after midnight, distribution always comes first. So we're going to distribute, and we're going to end up with y plus 11 equals negative 7x, careful with the negative signs, plus 14. All right, we almost have y by itself. We almost have point slope form. We're going to move that 11 over by subtracting it from both sides, and we're going to end up with y equals, I'm going to leave some space so we can change it to f of x, unless they give us y. No, we're going to do f of x. Y equals negative 7x, 14 minus 11 is a positive 3. And then the last thing I'm going to do is just to be careful because they gave us an f function. If you look up in the problem, up here they said f of 2 and f of 4, so we know the function is f of x equals negative 7x plus 3. And that is in the format they asked for, slope-intercept form. And side note, if you want to make the side note, you can. I know it's getting a little crowded. Negative 7 is your slope, and 3 is your y-intercept, which means 0, 3 is a point on your graph and is your y-intercept. Awesome. So that is finding an equation in both formats when you're given 2 points. Let's keep going. We have the exact same problem here, so I'll let you try it on your own. Really do a good job of practicing this so you make sure you master the material, particularly because this is the only section. Just make a little side note so you can get a head start on it. Perhaps the 2 points you should use are any 2 points from the table. So remember, a table is just a collection of points, and now it's the exact same problem as before. You could even call this point 1, so x1, y1, and you could call this green 1, x2, y2, and then you could solve it the exact same way we did before. The key fact there is remembering that a table is just a bunch of points. That table is just 5 points on that line. Cool? Awesome. We're going to hop down to graphing now. So, graphing using 2 points, probably the easiest way to graph, though I think they're all not too bad, but we are going to graph a line using 2 points. I give you 5 points here, but you really only need 2, so let's go ahead and get started. First point I always like to graph is 0, and I always put it in the middle. If you plug in 0, what does it spit out at you? If you plug in 0 right there, it's going to spit out 6. So another way to say that would be f of 0 equals 6. In fact, that's a special point on this equation, which I'm going to go ahead and graph. Should have used a color. That's okay. 0, 6. I'm plotting 1 point on the graph. And now, in order to graph a linear function, we really only need one other point. Because we only need one other point, if we were to, this is not the point, but if we were to put a point there, we could just draw a line straight through those 2 points and call that our function. But we need to find that point first. And in order to find points, I prefer picking nice, easy ones that I know are going to cancel. So I see that 4 on the bottom, and I think, oh, it'd be nice to get that 4 out of there. So I'm going to plot the point 4. I'm going to say, what happens if you plug in 4? I'm going to have to calculate this one. It's not as easy as 0. F of 4 equals negative 3 over 4 times 4 plus 6. You'll notice those 4s do a nice thing where they turn into 1, because 4 over 4 is 1, and you're left with negative 3 plus 6, which is just a positive 3. So you've got the point 4, 3. We'll go over to our graph and we'll plot it. 4, 3, and we have plenty of points to plot our line. So in orange here, I'm going to graph the line, and then I'm going to extend it out as far as I can. Being really careful. A little bit of pattern recognition is a cool idea too. Because we know the slope is constant, we could go ahead and analyze the graph and say, look, it goes down how many? Looks like it went down 3. And it goes over how many? 1, 2, 3, 4. So we probably have a slope of down 3 over 4. And remember, slope is rise over run. So our m value looks like it's going to be negative 3 over 4, which is our change in y over our change in x. Just a cool little side note. Then if you wanted to keep going, you could. I could erase this line and plot some more points by going down 3 over 4. 1, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. And all of these points, if we follow that consistent pattern, not only should line up, but they should also plug and chug into our equation to give us the equation for this line. Look at that. And so we have graphed our line, put some arrows so we know it goes on forever, using only 2 points and a little bit of pattern recognition. Awesome. Next thing you could do, which is pretty similar to what we just did, if you don't want to plug and chug 2 points and do that, you could look at the y-intercept and the slope if they give it to you in this form. So our y-intercept is 5, that's our b value, or 0, 5. And we have an m value of negative 2 over 3. So the first thing I'm going to do is I'm going to plot that y-intercept, 0, 5. That's our b value, that's our y-intercept, that's where this line intercepts the y-axis. And then I'm going to use the slope, which I know is m equals negative 2 over 3. So that goes down 2, and it goes to the right 3. And so I'm just going to go down 2 over 3. Down 2 over 3. Down 2 over 3. Down 2 over 3. And then you could even take it in reverse and go over 3, up 2. Over 3, up 2. Same thing. We're going to draw a line through all of these points. Make sure you line it up nice and neat. Draw your arrows so you know it goes on forever. And we have graphed an equation by just first plotting the y-intercept, that's that b value, 0, 5, and then using the slope to go either down or up, and then to the right, down 2 over 3. Awesome. So we've calculated slope, we've plotted lines. Let's see what they have in store for us next. Next, they have writing functions. I'll probably only do one of these. Let's try the other 3. But let's try the first one, which is this orange one. So let's try number 1. It says write the function associated with it. We're just going to observe whatever we can about a function. So if I look at that first one, I see it crosses at the point 0, 3, which means that the b value is 3. Well, that's half of my slope-intercept form. So probably the only thing I need to find now is slope and look for 2 nice, neat points. So I'm going to zoom in a little bit. So we have that point. Where's the next nice, neat point that I know it passes? Looks like it's right there. So what does this line look like it's doing if I'm reading from left to right? Looks like it goes up 2 and over 1. And remember, we've got a rise over run, and so our m is up 2 over 1. Those are both in the positive direction, positive y, positive x, and so they're both going to be positive, and our slope is just going to be 2. Well, 2 over 1, but 2 over 1 is 2. And so our function for 1 is going to be f of x is equal to mx plus b, where m is your slope, 2x plus 3. And that is our Roman numeral 1 function. Sweet. Another thing that's sometimes important, but a lot less common in the early stages of graphing, is finding the x-intercept, or finding the solution, or finding the root, finding where this line crosses the x-axis. And so in order to find an x-intercept, we set the function equal to 0. We say instead of plugging in 0 to find the y-intercept, we set it equal to 0 to find the x-intercept. So 0 equals all of this function. And then we just do our chapter 2 arithmetic and algebra to move over the 4, to move over the other 4 by multiplying by 4, and we get that x equals 16. Pretty important thing here, though, is x is not an intercept. X is just a coordinate on the intercept, right? The actual intercept itself would be 16, 0. And because this is a linear function, if we think about it, we've got a point at 16, 0, and we've got a point at negative 4, 0, negative 4 from our y-intercept, and we could graph our line if we wanted to pretty quickly, because we found 2 points. All right, let's talk briefly about horizontal and vertical lines, though I know we have already. Remember, if you remember back in the day when we talked about HOI-VUX, just an acronym I like to use, HOI-VUX. And that helps me just look at a line and know exactly what to do. So I look at this line and I say, that's horizontal, that's hoi. So this one is going to be a hoi because it's horizontal. The slope, I could go ahead and say m equals 0. That's what the 0 in the middle stands for, is 0 slope. And I could say that the y equals format of this line. And then we just look at what y is. If you just look at what y is for the whole line, look at the y-intercept for that, y is equal to -4, we got ourselves an equation because hoi helped us out. So the next one, because it's a vertical line, it's probably vux, which means it's vertical, which means this m is undefined, or there's no slope, because it's a straight up and down line. And if you look at what x equals looks like 7. And using hoi and vux, I think it's pretty quick and easy to find the equations of lines. Those are two pretty easy ones to mix up, though, between like which format to use. So really try to get that hoi vux down in your brain so you can look at an equation and know right away x equals or y equals. All right, last thing we're going to do in this whole section is look at parallel and perpendicular lines, which we already talked about again when we did equations. But just to remind us, parallel lines, the simplest way to remember it is same slope. And perpendicular lines, the quickest way to remember it that I do is flip-flip. But what does that mean? It means we flip the fraction, or the math word for that is reciprocal, and we flip the sign. The math word for that is opposite. We use the opposite sign. So here we go. Given the function, write an equation that passes through 0, 0. That's a point. That kind of indicates to me I might be using point slope form. And that is either parallel or perpendicular to that line. So 2 is our original slope. So parallel line is going to have, what does that mean? M equals same slope. So m equals 2. And perpendicular means flip, flip. Flip, flip, which means we're going to flip the fraction. So it's m equals 1/2 and flip the sign. It was positive, now it's negative. And now we just use the slope and the point they gave us to plug and chug into the point slope formula. So we've got y minus y1. I'm going to write this for both of them so we don't have to write it twice. And we'll just plug and chug 2 different times. Equals m x minus x1. So for this first one, this is the red one, the parallel line. We're going to say y minus 0 equals 2x minus 0. So really y equals 2x. That's not a nice, easy line. And for the orange one, for the perpendicular, we'll say y minus 0 equals negative, I almost missed that, 1/2 x minus 0, or y equals negative 1/2 x. All right. This try at 10 is putting everything together. If you can accomplish try at 10, you could probably accomplish everything we did today, because what it starts with the very beginning thing we did, which is here's 2 points. Use those 2 points to find m. Use m and the definition of perpendicular and a third point to find a perpendicular line to those 2 points that passes through that new point. So maybe I'll say that this is point 1, this is point 2, and this new one is point 3. So we could do x1, x2, x3, that kind of thing. So the first thing we're going to do, and I'll help you, I'll go through this, but if you want to pause the video right now and try to do this on your own, I would highly encourage that. It'd be a pretty good idea, because if you can do this, you can pretty much accomplish anything except for the graphing that we did in this section. So first thing I'm going to do, if you want to pause it, try it. But the first thing I'm going to do is I'm going to solve for m by going -3 minus 15 over 2 minus -2. -3 plus a -15, right? -3 minus 15. Just make sure I got my signs right here. It's going to be -18 over 2 plus 2 is 4. And so we end up, if we reduce that, to -9 over 2. There is our slope. Now, if we're going to use that slope and the definition of perpendicular, perpendicular lines mean flip, flip. So it's going to be new slope, let's call it m perpendicular. Our m perpendicular is going to be positive because we flip the sign, 2 over 9. And now using our formula of y minus y1 equals m x minus x1, though In this case, let's use 3 from the third point. We're going to go y minus 4 equals 2 over 9, x minus 6. And it didn't specify what format, so point slope form is just fine for that. All right, and there you have a whole chapter on linear equations, how to graph them, how to solve them, how to find perpendicular and parallel linear equations, and how to find slope given 2 points. Thank you for watching. Really, if you need to go back and practice some of these practice problems or look through the exercises in the book so that you're ready for the test coming up this week, I would highly encourage that so that you're prepared. Good luck in your studies, and I'll see you next time.